some notes. And these are notes about, well, direct variation is the first one, and we'll go down into inverse variation. So assume that y varies directly as x with some positive constant k. If the value of x increases, then the value of y increases. If the value of x decreases, then the value of y decreases. And we have direct variation, and I'll put a line that way it makes it easier to visualize which one's which. On the bottom, and I'll write in this case just on the right side, that way it's easier to see, inverse variation. Assume that y varies inversely as x with some positive constant k for positive values of x. So if the value of x increases, then the value of y decreases. If the value of x decreases, then the value of y increases. Okay. So in this case, just to make it a little bit easier to visualize, but be careful. For instance, inverse variation, we probably wouldn't have a 0 underneath. So that's the only case where we would have a hard time, right? But otherwise, for just quick visual, I'm going to state our equation, and then we will come up with a quick table. So for instance, y equals k times x is our equation for direct variation. And of course, we can always essentially use as an example y equals 2 times x, agreed? And let's say you have as a reference your calculator, and in this case, I'll just go to y equals, I'll plot x, and that should be 2 times x, so 2 times x. I'll go to zoom and do a zoom standard, option number 6, so go down to number 6 and hit enter, or push the button number 6, and you get a visual of what it looks like. It's just a straight line, okay, increasing straight line. But what I want to get at is the table. Second graph will give us the quick visual of the table, and I can probably get into the positive and negative sides of it, agreed? So let's fill in a table by making a table with our table, right? To make it easier to visualize. So there's our x and y axis, x and y labels, and there's our table values, and it's starting from -3 all the way down or up to +3, depending on how you prefer to see this, agreed? So there it is. So once again, quick values from our table to make a table. In some cases, they can become really useful, right? So for this case then, let me point out the fact that if we start at 0 for a reference, according to our direct variation notes, if the value of x increases, then the value of y increases. So if I increase the x value to 1, of course 2 times 1 gives us 2, right? And if I increase it to 2, 2 times 2 gives me 4. So I'm just plugging it into our equation in order to visually see it. 2 times 3 will give us 6, right? So it's increasing from what we can see. That's true. On the other hand, if the value of x decreases, then the value of y decreases. So let's check this out. What happens as we decrease the x value? So if we decrease the x value to -1, for instance, and this is one thing in just a visual representation. So -1 times 2 gives us -2. The value is much smaller by comparison, right? And it gets smaller even then. So such as -2 times +2 will give us -4. The quantity of the output is much smaller by visual reference, right? In other words, more negative. Okay, -3 times 6 will give us -3 times 3 will give us, times 2 will give us -6. There we go. Okay, and let's go for the inverse variation example now. Similar concept. Inverse variation, y equals k divided by x. Once again, it's a division for inverse, right? Inverse states a division. So our example, y equals 3x. So let's go ahead and go into our calculator. I'll go to y equals, and for now, I'll temporarily turn that off by hitting enter. So I'll go down to my enter button and hit enter. And notice if I go to the right, it turns it off. So it makes it basically unhighlighted. And I'm going to graph k divided by x, but in this case, it's 3. So it's 3 in our division sign, divided by x. So x. There it is. And it's highlighted there on the equal sign, right? So the equal sign there is highlighted. You'll notice once I move it away, there we go. Now you can see it's highlighted. That means it's going to be on. So I'll just do zoom standard, option number 6. Hit enter, or go to number 6 and hit enter. Either way will work. And this is kind of what it looks like for us, just for reference though. But I really care about the table in this case once again, so it makes it easier to visualize and understand the concept or the idea. And there we go. That's good. The fact that it starts at -3 and 3 once again for us. Otherwise, I'll move up and down in the table to make it start from 3 and go down to 3. That way we can get a better visual from the previous as well example. And we notice that at 0 we get an error. That's because we can't divide by 0, right? Anything divided by 0 is undefined. Okay, so now let me fill in my table over here. X and y values. And once again, this comes from the table on our calculator that we just saw. And fill them in. There we go. And now let's double check our statements here. So assume that the y-variance inverse is x with some positive constant k for positive values of x. In this case, notice I use negative values as well for reference to make it easier to visualize, but the idea still stands. Okay, so if the value of x increases and the value of y decreases, so what happens when the value of x increases? So if we have a 1, you have 3 divided by 1 gives us 3. Agreed? Okay, so the value of x increases, the value of y decreases. We start with a large number, in this case the 3, right? Now if we increase the x once again, now it's a 2, 3 divided by 2 gives us 1.5. Notice the y value is decreasing just as it stated. If I try it once again, I plug in 3 now, in this case 3 divided by 3 gives us positive 1. Definitely as you increase the x value, the y value decreases. That's a true statement from what we can see so far, right? So the next statement, if the value of x decreases, then the value of y increases. So let's try this out. What happens as we decrease the y value to -1? We get -3 once again. And that's a large negative, meaning it's a smaller quantity, right? Less desirable sign or amount, because it's more negative. So as we plug in -2, technically, right, which is a bigger -2, we get a smaller negative amount, right? So what do you prefer to owe on the bank? -$3, or do you prefer to owe $1.50, $1.50, right? So that kind of gives you a visual of what's more negative, what's a smaller quantity for reference as well. Okay, so it's definitely more desirable in this case to owe $1, right? So there's the -1 for the y value. When the x value is bigger, or pardon me, more negative, right? So it's a smaller quantity thing. We could think about this once again like the ocean, depth-wise, right? So does this help you visualize our direct variation versus inverse variation notes? If it does, great.